This video is a challenging one out of section 5.3, solving radical equations, and we're asked to solve a radical equation that has two square roots in it. Luckily this doesn't happen very often, but two different square roots, which means we can't just square both sides and get rid of them. It's not going to happen. So my first step is still isolate a radical. In this case, either radical will do, get one of them by itself. So what I did was isolated the square root of 5r minus 9 by adding 3 to both sides. Now my next step is to square both sides, just as it was before. That's how I'm going to get rid of a radical. But notice here, it's only going to get rid of one of these, because if I square both sides, the one on the left goes away, but the right side I have to actually FOIL square root of r plus 4 plus 1 multiplied by itself. So part of that will be r plus 4, but I'll have 1 times r plus 4, 1 times r plus 4 times 1. So literally FOIL out first, outside, inside, last. You still have square roots. What does that mean? Well, next step is isolate the radical that remains, square both sides again. So basically we start all over again and say, oh, well, could I get this square root by itself? So combine some like terms, bring everything over to one side, and ideally get the radical all by itself. So I get to this spot. This question, had we started with it, would have been a much easier question because we could just square both sides to get rid of that radical entirely, which means we do FOIL on the left side, and we end up with a quadratic to solve. Now, if you want to factor this, you could try to think what numbers multiply to give you 180 and add to give you negative 29. Some students are good enough with their numbers to do that. If not, you're heading to quadratic formula saying, okay, well, negative b plus or minus b squared minus 4ac over 2a. Pumping the numbers through. I won't waste too much of your time reading the numbers to you. But I end up with two answers like a lot of quadratics do. I got 9 over 4 and I got 5 as answers to this thing. If I stop there and circle my answers, I will have a problem. And that's why one of my steps at the end here says not just solve, but also check. If I come over to where I check these answers, checking r equals 5 all looks good. Stick a 5 into that original, right back to the beginning equation that we were solving. Stick a 5 into it for r, and you'll get 1 on left side, 1 on the right side. It works. Circle it. It is an answer. If you start trying to check 9 over 4, what you're going to see is at a certain point you end up trying to square root a negative. Well, that's not going to work. And so as soon as that happens, we don't even have to go any further. You can't square root a negative. It's extraneous answer. And so if you check the back of the book on this one, this was actually a textbook exercise. I think it was number 10 or something. You'll find there is only one answer given, r equals 5. But there's a lot of work to get there, as you can see. That's one of the most algebra intensive Math 20 questions that we have.